The purpose of this tutorial is to show you how to model aspects of building occupancy and operation which vary with time. During this tutorial I'll show you how the two main timing methods and the holiday option can be used to appropriately model the time-varying operational characteristics of the building, including the typical workday option, which is quick and easy to set up but provides less flexibility, schedules, which are the default timing option. These can take longer to set up but enable more flexible modelling of occupancy and operation to better reflect variable occupancy patterns, internal gains and HVAC system operation. And finally I'll look at holiday settings. Please note that this tutorial was produced during a period of transition to the UK 2010 National Calculation Methodology. Some of the activity templates and schedules are therefore likely to be labelled differently to those on your screen. Please ignore these differences, as they don't affect the concepts we're trying to teach during the tutorial. Future tutorials will be based on the updated UK 2010 NCM activities and schedules. Whilst the typical workday timing option is very quick and easy to set up, its lack of flexibility means that it is only really suitable for early stage modelling for most buildings. I'll start by going to Model Options, where you can see that schedules are selected by default. I can change this to typical workday by simply left clicking and dragging the slider indicator, like so, or by left clicking near the typical workday text. We can choose to set the operation times of our HVAC systems and equipment, such as lighting and computers, associated with internal gains, to match our occupancy profile by selecting one or both of these options. The typical workday timing option is loaded into the model when we click OK to make the changes and close Model Options. The on and off times and operational days per week can now be set for each relevant parameter, i.e. the occupancy and internal gains in the Activity tab, the operation of window shading, doors and vents in the Openings tab, different lighting options, and the ventilation, heating, cooling and domestic hot water in the HVAC tab. Note that an additional seasonal control option is available for relevant parameters, for example setting heating operation to winter only here. If the HVAC and internal gains to follow occupancy boxes were checked in Model Options, we lose the ability to set the on-off times for these elements, as they're controlled by the occupancy set times. However, we still retain the option to switch these items on and off using this seasonal control, and to select how many days per week they operate. I'll now go back to the Activity tab and set the typical workday parameter for occupancy. The default on-off times are set by the Activity template. We can set the occupancy start and end times either by clicking on and dragging the end of the time bar, or by using the up-down arrow controls for fine adjustment. I'll change the start and end times to 0600 and 2000 respectively, and increase to 7 the number of days per week that these on-off times relate to. The same method then applies to adjusting the Workday profile for the other time variable elements of the building. Given the simplicity of this method, you should now have sufficient information to enable you to use the Workday profiles. The second method available in Model Options is schedules, which provide a much more flexible method of specifying the extent and duration of time variable characteristics such as occupancy and internal gains and HVAC operation. I'll select the Schedules Timing option and click OK. Going back to the Activity tab, you can immediately see that the Workday profile time bar has been replaced by a schedule. The default schedules are again loaded by the Activity template. And you can see here that the abbreviated schedule name, Office, Open Office, Occupancy, reflects the Open Office template loaded above. Different schedule types for cooling, equipment, heating, lighting and occupancy have been created for each of the different activity types in each building category. Compact schedules are loaded by default, and some summary information is provided here in the info panel data report. Before discussing compact schedules, I'll discuss the simplified 7/12 schedules. 7/12 schedules provide a graphical representation of a schedule which allows you to select a different profile for each day of the week and each month of the year. They're more flexible than Workday schedules, but less flexible than compact schedules. We could create a completely new 7/12 schedule, but normally it's easier to copy an existing schedule which is the closest match to the one required and then edit it to suit. In this case, I'll create a 7/12 schedule to control the office equipment. So I first select and copy the default schedule, and using the edit tool rename it to Office, Open Office Equipment 7/12. I can then set the schedule type to 7/12 from the drop down list. I'll leave the default options set for the design day calculations, and more information can be found on this in the program help if required. The new profile is then defined by changing the appropriate cell values. I can change values in individual cells by selecting that cell, for example all Mondays in January, and select one of the available options such as 0900 to 1700 by either double clicking it or by selecting it and applying using the tick icon. I can use the same method to change all values in a row or column after selecting them using the row or column title cell as appropriate, which I'll now clear. I can also use the options in the info panel to make bulk changes. For example, selecting all weekdays and changing the schedule to say 0900 to 16:30, and then scheduling all equipment to off over the weekend. I can create my own profile if required, and again the easiest way to do this is to copy a similar one and edit it. I'll create my own profile, which I'll call tutorial. If you only need a single time period, you can use the default profile type and set it by adjusting the time bar, which I'll change to switch on the equipment at 0800 and off at 1800. Selecting the constant profile type results in constant operation with no off or setback period, but you can change the percentage operation to apply. If you select the custom option, you can change the percentage operation at different periods of the day. For example, to reflect lower occupancy and equipment use at the start and end of each day. You can also have up to 6 different settings per hour, but half-hourly changes will suffice for this demonstration, so I'll leave the interval setting at 2 per hour. The instructions for editing the individual profile time bars are shown here in the info panel. By right-clicking and dragging across the top of the time bar, I can extend the start and end times to 0730 and 1830. I'll reduce the percentage operation during the first hour to say 25%, to reflect low occupancy by left clicking and dragging down the time bar, then right clicking and dragging that across for the second half-hour interval. I'll also reduce to say 75% from 8:30 to 9:30 using the same method. I could use this method to reduce equipment percentage operation at other periods of lower occupancy, such as lunchtime or at the end of the day. Now that I've created that profile by clicking OK, I can load it into the 7/12 schedule for all weekdays. By selecting it and clicking OK. Clicking OK has now created the new schedule, which I'll load at building level by selecting the equipment schedule and applying it using the tick icon. The second and most widely used schedule type is the compact schedule, which uses a text-based data entry format. A compact schedule can be used to provide as many variations to the operation of each parameter such as occupancy, equipment, lighting, heating, etc., on as many different days or periods of the year as are required. Compact schedules are therefore the most flexible form of modelling the operating characteristics, but they do have a number of strict syntax rules. For this reason, it is even more beneficial to copy an existing similar compact schedule so that you only have to make relatively minor changes when editing the schedule to meet your own needs. These syntax requirements are fully described in the help file, and I'll only cover the basics here. I'll create a new compact occupancy schedule based on the existing OpenOffice occupancy schedule, which was loaded by the activity template. I select the occupancy schedule with a left click, then copy and edit the schedule using the info panel tools. I'll rename the schedule Office OpenOffice Occupancy Compact. In this case, the source data for the schedule is taken from the UK National Calculation Methodology. Some of the compact schedules have been created by Designbuilder based on the requirements of some national energy codes, and these should generally be used when undertaking modelling to demonstrate compliance with those codes. The profile data shows that the operational values are fractions. So for example, from 7 AM until 8 AM the occupancy fraction is 0.25, meaning that the model will assume only 25% occupancy. The resulting occupancy density used in the calculation from 7 to 8 AM will only be 25% of the full occupancy value defined by the activity model data, which you can see here. The through field here indicates that this schedule is applied from the 1st of January all the way through to 31st of December. Some buildings, such as schools, may have a number of different occupancy periods to ensure that the unoccupied periods during school holidays are included in the schedules. The for field here contains the days in the year on which the profile times and fractions apply, and in this case we can see that they apply to all weekdays and are also used for the summer design day, which is used by the cooling design calculation. The profile shows us that the occupancy from midnight until 7 AM is 0, i.e. the building is unoccupied. Then from 7 to 8 AM it's 25%. From 8 to 9 AM it's 50%. And then the building is fully occupied until midday. Similar profile changes are made in the afternoon, and the occupancy fraction reverts to 0 from 7 PM until midnight. Occupancy is set to 0 for all 24-hour periods during weekends, holidays, the winter design day, and all other days not specified by the above profile. We can easily edit the schedule data by editing the individual text entries. For example, changing the initial occupancy time to 07:30 or increasing the occupancy fraction to 0.75 between 8 AM and 9 AM. We can also easily create different profiles for specific periods of the year. For example, we'll assume that this office always closes down for the last week in December. I simply change the first through field to 24th of December, copy all of the data from the through field and insert it below the original data. Change the through date of the second period to 31st of December, and then delete all but the until 2400 period in the second data set. All fields in that final week of December are now set to 0 occupancy. It's important to note that the whole year must be covered for all day types in each compact schedule, even if you don't plan to simulate that part of the year. It can be easy to make a syntax mistake when creating or editing compact schedules, so Designbuilder includes a helpful syntax check within the dialog when editing compact schedules. Here, for example, when I select OK to confirm the changes to my revised schedule, I get an error warning which tells me that I should have replaced the semicolon at the end of the original profile with a comma, as it is not now the end of the profile. Once I've rectified that error and click OK, the schedule is created, and I can then load it by selecting it from the library list of schedules. Temperature setpoint schedules for heating and cooling plant are also loaded in compact schedule form by default. These are subtly different to other schedule types, so I'll quickly show you the cooling setpoint schedule and point out the main differences. The first difference is that the fraction field is replaced by a temperature field here. But the key difference is that this schedule only uses 3 operating values: 0, 0.5 and 1. 0 indicates that no heating or cooling is required. 0.5 indicates that the setback temperature setpoint defined in the Activity tab applies, and 1 indicates that the main comfort temperature setpoint applies. During the normal working week, including the summer design day, the plant operates to the main comfort temperature setpoint from 0500 until 1900. The plant is switched off at all other times, including weekends, holidays, the winter design day, and any other day not covered by the profile data. Setback temperatures are not used in this cooling schedule, but are often included in heating schedules to avoid the building becoming too cold when unoccupied at low ambient temperatures. I've just quickly run a cooling design calculation so we can actually see how the changes made to the schedules affect building operation and internal gains. It's important to note that the schedules are defined in local time, whereas the times shown on the results graph are solar time. This will be 1 hour earlier than local time when daylight saving is in operation, and 2 hours earlier in some countries during the summer. You can see that the equipment gains start at 7:30 local time and increase in 2 steps before reaching full load. The 2.965 kilowatt load here is derived from multiplying the floor area by 75% of the 15 watts per meter squared equipment gain set in the activity tab, as I set the operating fraction for that time period to 0.75 in the equipment schedule. The occupancy profile reflects the gradual increase followed by steady state fully occupied periods during the morning and afternoon, and a reduction at lunchtime. The occupancy levels tail off towards 0 at 7 p.m. Note that the cooling design calculation uses half-hourly time steps, so each time step on the internal gains graph represents the heat gain to the zone over the preceding half-hour interval. This is why the equipment and occupancy heat balances don't reach 0 until half an hour after the scheduled 0 time. Holiday periods can be specified at building level here in the Activity tab to include the effect of periods of no occupancy in simulations, but are not included in heating and cooling design calculations. Holidays specified in the Activity tab in this way are additional to any holiday periods which have been specified in compact schedules. Looking at the typical UK holiday schedule, which has been loaded by the Activity template, the possible holiday dates are shown here in the List tab, and the holidays which are most likely to be taken are listed at the top. The actual holidays used in the simulation are the number of holiday days specified here. And are selected in order, starting from the top of the schedule list and working down. So for example, if only 2 days were specified, the simulation would model the 1st of January and the 25th of December as holidays and ignore the remainder. Holidays are modelled using the fraction or temperature value set in the relevant schedules. So for example, the cooling plant would be set to off during holidays in our model, as it has a value of 0 in the cooling temperature set point schedule as discussed earlier. In this tutorial I looked at the methods of controlling the occupancy and operational time variable parameters of the model. The tutorial has hopefully demonstrated how easily you can load or create your own profiles and schedules in Designbuilder to help you accurately model the operational characteristics of your building.